In this video, I'm just going to look at a bit of an introduction to the unit circle. Now, when we talk about the unit circle, we call it the unit circle because it's a circle with a radius of 1 unit. So I'm doing a very wonky circle around there, but I would have a 1 there, -1, -1 down here, and 1 up the top there. So please bear with me with my very badly drawn circle there. So that's the first thing to know about the unit circle. That's why it's called the unit circle, because it is 1 unit. That means we can base a lot of information on that, because the radius at any point on that circle is always going to be 1. The other things to know about the unit circle, we always start at 0 over here, and we're working around anti-clockwise. So this is very different to when you're doing bearings. And I realise that does make it confusing for some students who have just got their head around bearings. We're now labelling differently. So we've got our 0 here, our 90 goes up the top, we've got 180 over here, and 270 down the bottom. The next thing that you're going to notice with your unit circle is that we will also talk about things in terms of pi. So when we talk about pi, and we're talking this in terms of radians, so this is a new thing that you'll be getting into looking at radians, we have pi is equal to 180 degrees. Now you've been used to using 3.14. So when we're talking radians, if we're talking about pi, we know it's 180 degrees. So if we've got a 90, that's going to be pi on 2, because that's a half of 180. Over here at 180, we've obviously got pi. Down the bottom here, we've got 3 pi on 2. And then once we get back to 0, we've gone around 2 pi. We can also put a 360 there if we want our degrees. So knowing that and knowing how we set up the unit circle is very important when we're doing any unit circle type calculations or exact values. The other thing to know, and if you're starting in unit circle, is to remember some of the very well-used angles that we will refer to. So the ones that we use a lot are 30 degrees, 60 degrees, and 45 degrees. Now, 30 degrees, when we've got it in radians, is going to be pi on 6. 60 degrees is pi on 3, and 45 degrees is pi on 4. These are super important to learn off quickly, because that's going to make everything that you do so much easier if you know those conversions. The next thing to be able to do is to draw angles on the unit circle. So we call this quadrant here our first quadrant, where everything is positive, and so all of our ratios, sine, cos and tan, are all positive in that quadrant. We then have this quadrant down here where we have only cos is positive, and we will get into why that works. Over here, only sine is positive, and over here, only tan is positive. This is all to do with what the coordinates are in those sections. So here we've got all our positives. So positive divided by positive when we're doing opposite over adjacent, or opposite over hypotenuse, or adjacent over hypotenuse. If we've got a positive number divided by a positive number, it's going to be positive. Over here, the x value is negative. Now, the only one that doesn't use, if we drew in a triangle over here, and brought it down, tan and cos all use that adjacent side there, which would be negative. Sine uses the opposite side, so if we put a little theta there, so it doesn't use the negative value, which means it can still have a positive answer, because it will have its 1 for the hypotenuse, and then this positive value here for the height, or the opposite value. So what we'll do when we do these questions is do a lot of drawing on the unit circle. So if we draw one in the first quadrant, that's always called our reference angle. So we'll pop one there. Then we know that there is symmetry in our unit circle. So if we draw one the same angle over here, they're going to be equal in value. They may have a different sign, so they may be negative depending on what ratio that you're looking at. In the same way, we can also draw another one down here and another one down here. So these all have the same angle from the horizontal, which means their numerical value will be the same, and you may just have a negative answer depending which ratio. So if we pick one to look at, so if we look at our 30 and pretend this is 30 here, we would have our 30 degrees as our first quadrant reference angle. Now if this was 30 over here and we know that the whole way around is 180, then if we've only gone this far around, I'll grab another colour, then that must be 150. Then if we had this one over here, and I'll grab another colour, and we've gone all the way around to this line, we've gone all the way to 180 plus another 30, which is 210 degrees. Then for our last one over here, we've almost gone the full circle, but not quite, so we've gone minus 30 degrees, so that would be 330 degrees, that one there. I'm then going to grab my calculator and have a look at some of these ratios. So first I'm going to look at sine. So if I do sine of 30, I get a half. If I do sine of 150, I get a half again. Now I did say sine would be positive in that quadrant. Here then, following that pattern, I should get half and half, but both of them should be negative. So let's check. 210, sine of 210 gives me negative a half. And then if I do sine of 330, I also get negative a half. Now I could have also gotten to this part down here by doing negative 30. So if I do sine of negative 30, I also get the negative a half. And I could do the same the other way. So we can go forwards and we can go backwards in the unit circle. If we have a look at cos, thinking through the pattern, we should then get positive in the first quadrant. We should get negative here, negative, and then positive. So if we do cos of 30, we get root 3 on 2. If we do cos of 150, we get negative root 3 on 2. And that was what we were expecting. If we do cos of 210, then we're expecting it to be negative again. Negative root 3 on 2. And if we do cos of 330, that's the quadrant where cos is positive, so we should expect it to be positive. And we get a positive number. We could also do that with tan, and we would say the same pattern occurring there. So I'll let you have a look at that one yourself. I'll make a couple more videos on the unit circle that you can have a look at as well. And hopefully that helps you along the way with how to use your unit circle.